Well, this is a Shockflo 40 amp EV charger. These currently, as of 2025, are all over eBay for just over $50, which to me seems quite a decent price for just getting one to tear apart and experiment with. And yes, I did remove the internals, all of them, because this looks like a fairly hackable charger for something that I can use to dynamically control charge output as well as charge on off and stuff like that. We could make it for home assistant or otherwise. First, I was looking at the board, display side, which goes right under here to give you a nice little graphic, and the two buttons are on the connector there. First thing I noticed, thanks Shockflo, I appreciate it a lot. They didn't erase any of the chip part numbers. So this is actually a giga-device semiconductor 32-bit ARM processor. We have a standard 160x128 LCD that I easily get a datasheet for. Discrete logic and stuff like that. Connectors go to the other board. I spent some time reverse engineering this circuit to figure out how it works, so I can write code for it. That's what we have here, basically trying to find out what are the pins of each part. There's the connectors on the side, and I'm going to identify what each signal does, or at least most of them. Display connection, stuff like that. The buttons. Turns out the buttons are on top of what would be an I2C EEPROM. So that's fun. So this is there's the part number right there, GD32F310C8T6. That gives 64K of flash, 8K of RAM with a 32-bit ARM processor, which is not very much when you're dealing with a graphical display like this. It is worth noting that this header up here, which I soldered in, I figured out this RK, so R is reset, K is SW clock, D is SWDIO, G is ground, 3.3 volt. That's all I need to reflash it, or in this case, read it out with a DAP link, CMSIS DAP. This chip is not encrypted. I was able to read the entire 64 kilobyte memory space out, and of course it's binary, which is not super helpful, but I was able to read strings and stuff. Also of interest on here is our ground. We have our enable, which this was RS485 enable, RX and TX. So out of the box, RX and TX provide a 115-200 baud serial interface of some sort. By looking at the dumped binary from this chip, I was able to find a lot of strings and things that it supports and accepts. But what I was not able to get it to do is things like change charge current, turn on and off, other valuable stuff. Besides, we might want something more like Modbus or something a lot more useful on those pins. But this chip has two UARTs. One of them is here. Another one goes over this connector to the other board, which has all of the logic on it. So, other board is the main one, which goes in the bottom right here. And we have a lot of similar stuff. I'm not going to do an exhaustive review on this. I'm sure other people are going to go into the nitty-gritties. But basically we have an HT7017 power monitor chip up here, which monitors the voltage right here. This is ZMPT107, which is an isolation transformer for voltage monitoring. We have a current sensor for monitoring actual current, a differential current sensor for leakage, and next to it is a leakage chip right there. And a lot of miscellaneous stuff, our power supply, latching state relays, bistable relays, a negative voltage generator with a capacitor charge pump, so it takes plus 12 volt from here and generates minus 12 for the output right here, which the CP is the J1772 control signal. So we also have a voltage feedback, so we know there's an output, like the relay's turned on, we have a voltage feedback all the way back. These transistors form a totem pole driver for plus minus 12 volt drive on this. It's funny that the processor has to use a driven PWM or set the pin to high Z, as in input state, to not drive this, so we can see what the car is requesting. So the root schematic up here is this board here, which I had to do a lot of reverse engineering and filling parts in to figure out how the circuitry worked. You can see the totem pole driving, and the op amp here is just being a buffer, and for whatever reason this is pulled off this side. I didn't see anything pulled on that side. There's the output sense, the relays. It appears here that I only put one relay in. I'm not trying to get an exact replica here. I'm just trying to figure out what circuit does what. So the leakage detect IC, the FM2147, we have a hardwired threshold here, 4.7K, 15K, and an AND gate that the processor can enable or disable. So if there is a leakage over the threshold measured by this, it will automatically trip and shut the relays off through D13, D14, and then to Q12. So also notice up here there's a 5-volt regulator hiding right up there in the corner. It is not used on the display board, and it's a linear regulator, so whatever they're doing with that, I have no idea, but it's there. So my goals with this is to put this information up on a GitHub. And if anyone else is interested in collaborating or hacking on this, to write more usable firmware for it, so a lot of people can benefit from a 40 amp car charger that can be controlled to your heart's content over serial up here, let the fun begin. It's only $50 right now. What is there to lose? Let's have some fun.